87% of the world carbon emission comes from cooling alone, partly because refrigerators run all the time, but the other more important part is because we use chemical refrigerants called HFC, which have global warming potential thousands of times as much carbon dioxide. And for that reason, they're currently being phased out in favor of a more eco-friendly refrigerant like natural refrigerants. Unfortunately, the alternative is highly flammable and poses serious risk. So there is no alternative, a safe alternative to go to. On the other hand, the technology that we use nowadays called vapor compression was invented more than 100 years ago and is very slow. So it creates a lot of issues in business, especially in the industrial and commercial usage. So there is a need for a newer, more efficient and cleaner cooling technology to meet the challenges of the 21st century. Introducing V-chiller. We developed a new cooling technology based on vacuum cooling instead of vapor compression that offers cleaner, more efficient, and faster cooling. Let me explain to you how it works. You might read here like cold boiling, sound like a mad scientist experiment, but it's not. Actually, how it works is pretty simple. So water boil at 100 degrees C, for example, at 1 atmospheric pressure at sea level. If we take water all the way up to Mount Everest, the pressure there is a third of what it is at sea level. So water starts to boil at 70 C only. If we take water all the way to space, there is no pressure at all. Water keeps boiling until it totally freezes. And this is exactly how V-chiller works. We place a certain liquid in an airtight chamber, and we depressurize it using a vacuum pump. Under the negative pressure, the liquid starts to boil. Because we're not adding heat for the system to boil, the heat required for the phase change comes from the liquid itself and its surroundings. Hence, you get the cooling effect. This process happens so fast, so you get rapid cooling effect on top, which is totally new to the world. So as I said, you get rapid cooling. It's a new, we have tons of application from this. Actually, it's opening the door for a new application, actually. After only 4 years of development, we managed to reach efficiency almost the same or exceeding vapor compression. The refrigerant we built is totally eco-friendly and it's non-flammable. So we basically solve all the problems the world is facing right now. This technology have a lot of applications. We can build air conditions, data center cooling, and much more. So working with our partners, AB InBev and Coca-Cola, we decided to tackle a problem that have been going through with the business of beverage industry for so long, which is how can you cool beverages on demand at the point of sale instead of mass chilling large number of beverages all the time, wasting tons of energy. So we come up with a new solution called V-chiller instant. It's a vending machine style. So how it works is it rapidly chill a number of beverages and keep it in a thermally insulated chamber so you don't lose any heat. Once a customer presses a button, they get the drink right away. No waiting time. The machine automatically takes a warm bottle and then rapidly cool it and store it. And with this concept, we can replace 4 coolers because it have very high capacity. The energy saving you get is around 50% because you're only running the machine when you're actually selling it instead of running it 24/7. The more important part is with typical cooler, during peak time when people are buying a lot, you open and close the door a lot of time. And this ends up introducing a lot of warm air inside the machine and warming up the entire stock. So you basically, nobody likes warm beer. So you basically lose a lot of sale. With V-chiller, everything is insulated. So you get a perfectly chilled drink every time. Our goal is to help the world transition to a more eco-friendly and added a lot of economical benefits and application to the world. In the same time, offer our customer the best customer experience ever. Thank you very much.